everyone. So in this video we're going to be solving a compression problem. So the problem statement is basically we'll be given a sentence. So the sentence will contain a group of words. So algorithm should reverse the words order of words in the given sentence. For example, if you take this string as input, so it has three words: reverse followed by this and followed by string. So basically, our algorithm should reverse the order of these words. First, we should have a string followed by this, followed by reverse. So this should be the output of our algorithm. So that's what our algorithm should do. And one point we should keep a note of it is so the input string may contain leading or trailing spaces. So basically, and our output string should not have any leading or trailing spaces. And also our input can contain multiple spaces between a word, between two words. So, but however, our returned the output of the our algorithm should only contain a single space between each word. So, this is something which we need to keep a note of it. And remaining everything is same. We have just have to reverse the order of words in the given sentence, which is given in the form of a string. Yeah, so we'll be seeing two approaches to solve this problem. So in the first approach, basically we'll be splitting the given sentence, which is given in the form of string, to an array of words. So basically we'll be splitting the given sentence into array of words by one or more spaces. So since we have discussed that there may be chance to have multiple spaces between words. So we'll be splitting the words by one or more spaces, and we'll be storing it in an array of strings, and then we'll be returning, and then we'll be joining the array of strings from last to first, so that we'll be having our required string, which is nothing but the words reversed in a given string. Yeah, so this is the idea of this approach, first approach. So over here, first we'll be trimming leading and trailing spaces, since we don't need to have this leading and trailing space in our output. And next, we'll be splitting this given sentence into words. So since we have to split these given words by one or more spaces, we'll be using a regular expression. So we'll be using this slash slash s plus. We'll be using this regex pattern to split the sentence by one or more spaces. Now we'll be having the array of strings, which is nothing but array of words. So we'll be joining this array of words in reverse order, so that we'll be getting our required string, which is nothing but the words reversed in a given string. Yeah, so this is our algorithm. So over here we can see the computer program of our algorithm, which is written in Java programming language. So this is the method which contains the core logic of our algorithm. The method name is this reverse words in a given string. So this basically takes a string as an input, and then as we discussed, first we're going to be trimming the leading and trailing spaces using the trim method of the string class of Java, and then we'll be splitting the given string by one or more spaces. So we'll be using the split method, and inside we'll be passing a regex pattern slash slash s plus. And now we have the array of strings, which is nothing but the array of words in our given string. So now I am initializing a string joiner object. So basically the string joiner object, we are passing a empty string as an parameter to it while creating this object, so that when we add any string to this object, so each string which we have added will be separated with this empty space character. Yeah. So now, since we have an array of words, we'll be looping all the way from last element of this word, which is nothing but n minus 1th index, to the first element. And then we'll be adding this strings to this string joiner. So, and at the end, we'll be converting the string joiner object to string and we'll be returning this. So this is how the computer program for this algorithm looks like. So the time complexity of this algorithm is big of n. So where n is nothing but the number of words in the given string. Whereas if you see the space complexity, it will be as well big of n. So here if we see the trim function does not do use any extra space because it is simply just returning a substring of the given string, right? And we are storing this substring in the given string object itself, so it does not take any extra spaces. However, the splitting function here creates an array of substrings. So suppose if it assume n is the number of words in the given string and L is the length of the string. So the space complexity for storing array of words will be like big of L, where L is the number of words in the given string. And then we are constructing a string joiner object, and then we are adding the strings to it. So the space complexity of the string joiner depends on the number of characters in the given string. So for suppose if we assume the number of words in the given string is L, so the space complexity is big of L. So putting all together, the space complexity of this algorithm will be like big of L, where L is nothing but the number of words in the given string. So the time complexity and space complexity will be of big of N. Yeah, so this is what is about approach one. So now we'll see the approach two. So in approach two, we'll be decreasing. Our goal is to decrease the space complexity since we can't decrease this time complexity. So we'll be focusing on decreasing the space complexity and achieve a constant space or auxiliary complexity. Yeah, so for that, since in this approach one, we are using an extra space, right, for splitting the string and constructing a new string in order to reverse the words in a given original string. So we'll be rather than using this extra space, we'll be reversing the words in place within the given input string. So, but as we all know, since Java string class is immutable, right? So we can't modify the string in place. So instead, what we'll be doing is we'll be converting the given string to an character array. So and then we'll be manipulating this array in place. And then at the end, after we do that, we'll be converting our character array back to a string. So this is the idea of approach 2. So if we see, this is the computer program for this algorithm. So this as well is written in Java programming language. So this is the method. Let me just, yeah. So this is the method where which contains the core logic of our algorithm. So the method name is reverse words in a string. So which takes the string as an input. And then as we have discussed, first we're going to be converting the string into a character array. Before that, we'll be trimming any leading or trailing spaces. So after we have an character array, first we'll be going through three steps. First, we'll be reversing the entire character array, so which is nothing but we'll be reversing the entire string. It is nothing but we are reversing the entire characters in a given string. So and then we'll be returning each word in a given in the string array, in the character array. So our input is like sentence. Sentence is nothing but group of words. First, we'll be returning the entire string. It is nothing but reversing the entire words in the string, and then we'll be reversing each word in the in this string. And then at the final stage we'll be clearing the multiple spaces since we don't need multiple spaces between words in our output. We'll be clearing it, and also we'll be clearing any trailing or leading spaces if any. Yeah, so this is these are the steps in this approach. So first, if we see the reverse method, So basically it takes three input. One is character array and other is two integers, which is named as start and end. So basically, the usage of the start and end index is to tell this method to reverse the characters in this given array, starting from index start and ending with the index value of end. So that is what we are doing over here. So here we are starting a loop, so with the condition start less than n, and then we are swapping the values at index start with the value at index n. So basically this will swap all the value. Basically this will reverse all the characters from the index start to the index end. So since we are using this method and we are passing the start as value 0, which is nothing but first element of the character array, and the next n value as n minus 1, which is nothing but the last index of the given array. So basically this will reverse the entire character array. And next we'll be calling this method, so which is nothing but we'll be returning reversing the words in a given character array. So in this method we'll be using basically we'll be using two pointers. So one is start and one is end, both initializing from the first element of the array. So then we'll be looping through this character array using the start variable all the way from first element to the last element. And inside this we'll be moving this end variable. Basically we'll be skipping we'll be moving all the way from first element till this end variable is pointing to a empty string. So when it finds an empty string, we'll be stopping this end. So now the start will be pointing the start of a word and end will be pointing to the end of a word. So now we'll be calling this method, which will return in, which will basically reverse the character array between the index start and the index n minus 1. Since n is pointing to an empty string, we'll be using passing as n minus 1. So once we have done that, we will be moving the start variable to the beginning of next string. So now since end is pointing to a empty string, we'll be moving start to n plus 1, and we also will be incrementing n to the next element n plus 1. So now start and end both will be at the same position, and in the next loop the same thing goes on. We'll be moving end variable to the end of this word, and then we'll be returning the string, and then we'll be moving the start to the beginning of next word, and we'll be keep on going until we are done reversing entire words in the given character array. So this is how this method works. And finally we'll be calling this clean spaces method. So over here the main use of this method is to basically remove multiple spaces between words in the given string, and also to remove trailing spaces or any leading spaces if any. So basically this method will take this character array as an input, and over here as well we'll be using two pointers m, I and j, so both initializing from the first element of the array. So first we'll be looping all the way from first element to the last element of the given character array using the variable j, and inside this first we'll be running a loop to skip the spaces. So since j is starting from 0, we'll be skipping all the spaces from the start. So basically we'll be skipping all the leading spaces, and when j finds a non-space, we'll be placing the non spaces from the position I. So basically the j will be j will be pointing to a non-space. Suppose if we assume j is pointing to 3, and 3 index, third index is the first non-space, and I is at 0. So now we'll be placing the word starting from 3 uh, and keeping it in the array, in the same array, which is starting from 0. So we'll be, suppose if the first word is starting from 3 to 5, we'll be keeping this 3 to 5 from 0 to 3. So that is what we are doing over here. We are we are taking the string, we are taking the word and keeping at the uh, first position, starting from I equal to 0. And then after we keep all the non spaces, we'll be again checking whether there is any non-space after this. So now j is pointing to a non-space, so it will only stop when j is pointing to a space. So now we'll again skip all the spaces, and at the end, when if j is pointing to a non-space and if still j is less than n, we'll be adding a space at the end of the first word. So basically, why the reason we are skipping these spaces twice, right? Again in the same loop. So it is to make sure we don't add any trailing spaces. So so suppose if all the elements after j are empty, then we'll be adding it trailing space if we don't check there is any spaces after j. Suppose if the end of this second loop, if j is at the index where j is empty, right, and all the elements after j are empty, so it is nothing but j is at the trailing spaces. In this case, if we don't check whether there is any non-space after j, so we'll end up adding a trailing space in our end result. So to make sure that we will be checking whether there is any non-space after j. So so this is how this method works. At the end, we'll be creating a new array all the way from 0 till the index I. So the index I will be basically will be pointing to the end of last character of the of a word, of the last word. Yeah. So so this is what we'll be doing. uh, so this is how this algorithm works. First we'll be returning the entire array, character array, and we'll be reversing and each word in the character array, and then we'll be handling the multiple keys, spaces between words, and if there we'll be cleaning if there are any trailing or leading spaces, if any. Yeah, so this is how this second approach works. So over here, the time complexity will be like big of n. Will be like we're doing ones, and ones. So it will be like big of in order of big of n. But however, the space complexity of is a constant, which is nothing but big of one. Since we are not creating any new array or any new data structure, we are just converting our string to a character array, and we are manipulating it in place, and we are returning a string using by using this character array. Yeah, so that's why the space complexity will be like big of one, which is nothing but a constant space complexity. Yeah, so this is what how to solve this problem, reversing words in a given string. So I'll be giving the link of this notes in the description of this video, so that you can go through this. So basically, this sheet will contains many other problems which can be solved using this two pointers approach. Yeah, so that's it for this video. See you in the next.